Okay, in our previous session, we looked at theoretically how to solve linear differential equation of second order with variable coefficients. Now here we are actually going to look at a specific problem. So let's say the problem given to us is d2y by dx square times x minus 2x plus 1 dy by dx plus x plus 2 y is equal to x minus 2 e to the power of 2x, and it is given that x is greater than 0. Now, since x is greater than 0, it means we can just divide the entire thing by x to get rid of this x. Had it been less than 0, then it would have been a problem. Why? Because then the sign would have also changed. So let's divide the entire equation by x. We end up with d2y by dx square minus 2 by x. So x by x is 1 plus 1 by x dy by dx plus again x by x is 1 plus 2 by x y is equal to 1 minus 2 by x e to the power of. So if we look at our standard form, this would be p, this would be q, and this would be r, right? So p would be minus 2 times 1 plus 1 by x, q would be 1 plus 2 by x, and r is equal to 1 minus 2 by x, right? Now, one more thing that we needed was a integral, right, of the complementary function, but we have not been given. So which means we have to figure out an integral of our own. In the previous session, at the end, if you remember, we saw that the integral would be e to the power of x if 1 plus p plus q equal to 0. It would be e to the power of minus x if 1 minus p plus q equal to 0, and so on. Remember that? So let's see to which category it falls in. So p plus q plus 1 equal to 0. Let's try this first. So p is minus 2 by x plus q is 1 plus 2 by x plus 1 equal to 0. Now minus 2 by x cancels. 1 plus 1, 2 minus 2 is 0. So this is the one, which means y is equal to e to the power of x is an integral, right? So we can say let the complete solution be y is equal to e to the power of x times v. And what we have to do is we have to figure out v. Here v is a function of x, which we have to figure out. Okay, so let's begin. Y is equal to e to the power of x times v. Once we put this in our standard equation and go through the process that we saw in the previous session, what we'll end up with is d2v by dx square plus p, we have already used it, so p1 dv by dx is equal to r1. Okay, now here p1 is going to be equal to p plus 2 by u du by dx. Here u is what? If you remember, y is equal to u times v. That is what we looked at in the previous session. So here u is nothing but e to the power of x. So u is equal to e to the power of x. So which means du by dx is equal to e to the power of x itself, right? So what is p? P is minus 2 times 1 plus 1 by x plus 2 by e to the power of x is u. Du by dx is e to the power of x. So these two cancel out. And what we end up with is minus 2 minus 2 by x plus, so here 2 and 2 cancel out and we are left with minus 2 by, okay, let's try to figure out R1. R1 is equal to R by U. Now R is 1 minus 2 by x e to the power of 2x by U. So U is e to the power of x. So which means this and this cancel out. And we are left with 1 minus 2 by x times e to the power of. Okay, now let's see. Now what we have is d2v by dx square plus p1 dv by dx is equal to r1, right? Now if we do the substitutions, what we'll end up with is d2v by dx square plus p1 is minus 2 by x, so which means we can remove this plus and take minus 2 by x dv by dx is equal to 1 minus 2 by x to the times e to the power of x. Now we don't really require this second order, so what we'll do is we'll say let dv by dx be equal to z. That means d2v by dx square would be equal to dz by dx. And now we do the substitution. So d square v by dx square is dz by dx minus 2 by x, and dv by dx is z is equal to 1 minus 2 by x times e to the power of x. Now this is a linear differential equation of order 1, which means we know how to solve it using integrating factor. So integrating factor would be e to the power of integral of minus 2 by x dx, which is equal to e to the power of minus, we can take it out, actually minus 2 can be taken out, integral of 1 by x dx. Now because the exponent is negative, we can take the whole thing down. So 2 integral of 1 by x dx. Now let's take the integral. So e to the power of 2, 1 by integral of 1 by x is log x, which is equal to 1 by e to the power of log x square, which is equal to e and log cancels out, 1 by x square. So our integrating factor is 1 by x square. Now let's again bring in the equation dz by dx minus 2 by xz is equal to 1 minus 2 by x times e to the power of x. Now we have to multiply both the sides by the integrating factor, that is 1 by x square. So we end up with 1 by x square dz by dx minus 2 by xz is equal to 1 by x square 1 minus 2 by x e to the power of let's distribute this. We end up with 1 by x square dz by dx minus 2 by xz, and this x, because x square is coming in, so this becomes x cube, is equal to 1 by x square 1 minus 2 by x e to the power of x. Now remember, we don't really require dz by dx, we want to get rid of it, so which means we have to integrate it. Okay, so integrate both the sides, so which means constant of integration will come. Now let's write dx. Now how do we integrate this? If you look at this, here you have z and here you have dz by dx, right? Here you have 1 by x square And here you have minus 2 by x cube, right? So which means this is its integral is 1 by z times 1 by x square is equal to integral of 1 by x square times 1 minus 2 by x e to the power of x dx plus c1. Let's open up this bracket. We get 1 by x cube e to the power of x dx minus 2 by x cube e to the power of x dx. Let's keep it together itself plus c1. dx will go out of the bracket. dx plus c1. Now let's write it in this form. In this form. X minus 2 e to the power of x. Let's split it. dx minus 2x minus 3 e to the power of x dx plus c1. Okay. Now we do this. If you look here, let's solve this first. Let this be as it is. And this we will do it using integration by parts. Okay, so this would be what? Minus is outside. This is going to be 2 differential of this. So minus 3 plus 1 by minus 3 plus 1 e to the power of x minus integral of the differential dx 2x minus 3 plus 1 by minus 3 plus 1 e to the power of x dx plus c1. Now let's simplify this. X minus 2 ex dx minus 2x minus 2 by minus 2 e to the power of x minus integral of 2x minus 2 by minus 2 ex dx plus c1. Okay, now x minus 2 x minus 2 ex dx. Now this minus and minus plus it becomes 2 and 2 gets cancelled. X minus 2 e to the power of x, and again here we have minus minus plus times minus minus. So minus integral of 2x minus 2 by 2. So 2 will cancel out actually. So this 2 and this 2 will cancel out. So x minus 2 e to the power of x dx plus c1. If you notice, this and this are same, so they both cancel out. And we are left with x minus 2 e to the power of x plus c1, right? So this is z times 1 by x square. So z would be equal to x square times x to the power of minus 2 is 1 e to the power of x plus c1 x square. Now z is dv by dx is equal to e to the power of x plus c1 x square. What we want is v. So v is the integral of this. So integral of ex is ex plus integral of this. So c1 x cube by 3 plus constant of integration, another one. So our complete solution would be, remember, y is equal to uv. So u as it is, v is going to be, no, u is actually e to the power of x times v is e to the power of x plus c1 x cube by 3 plus c2. And what we can do is e to the power of x by 3. So this becomes 3e to the power of x plus c1 x cube plus 3c2. Okay. So this is our full solution. Now, sometimes what will happen is we have to figure out C1 and C2 as well. Now, to be able to figure out that, some additional information has to be given. If it is provided to us, we might have to, for example, let's say it is given that y of 1 is equal to 0 and y prime of 1 is equal to 0. Okay, since this information is given, we have to come out with the equations. We will end up with simultaneous linear equations in C1 and C2, and that we have to solve. So y1 is y is equal to what? We already have this 1. So y1 would be equal to e by 3e plus c1 plus 3c2. Now, sometimes what will happen is some additional information will be given, and based on which you have to figure out the values of C1 and C2. Okay, let's take care of this additional information to get C1 and C2. So y of 1 is equal to e by 3e plus C1 plus 3c2, which is equal to we know it is given as is equal to 0. So let's take care of this. This actually, when we take it to the other side, it becomes 0. So we are left with 3e plus c1 plus 3c2 equal to 0. Now the other information that is provided to us is y prime of 1 equal to 0. So first let's figure out y prime. Y prime is going to be the derivative of e to the power of 2x plus c1 x cube ex by 3 plus c2 ex. So let's differentiate this. We get 2e 2x plus c1 by 3, and we have to apply the product rule. 3x square e to the power of x plus x cube e to the power of x plus c2 e to the power of, right? And now let's take y prime of 1. So which means this becomes 2e square plus c1 by 3e plus x cube is 1, e to the power of x is e plus c2e. 2e square plus 4e c1 by 3 plus c2e, right? And here we can take out e common. 2e plus 4 by 3c1 plus c2, and this we are given that it is equal to 0. So which implies that e will get cancelled when we take it to the other side, and we are left with let's take the LCM. So 6e plus 4c1 plus 3c2. The denominator 3 will go to the other side and become 0. So this is our second equation. So first equation was 3e c1 3c2. 3e plus c1 plus 3c2 equal to 0. Now let's subtract it. Why? Because these two are same. So c2 will get eliminated. So minus minus minus. This gets cancelled. This becomes 3e plus 4 minus 1, 3. 3c1 equal to 0. 3 is common. So let's take it out and take it to the other side. It becomes 0. So we are left with e plus c1 equal to 0. So c1 equal to minus e. Now let's put this c1 in one of the equations. Doesn't matter which one. So let's take 6e plus 4 minus e plus 3c2 equal to 0. So 6e minus 4e plus 3c2 equal to 0. 2e plus 3c2 equal to 0. And 3c2 is equal to minus 2e. So C2 is equal to minus 2 by 3. So our overall equation or solution becomes y is equal to, remember we have e to the power of x, e to the power of x plus c1 x cube by 3 plus c2. So we just substitute the relevant values. E to the power of x, e to the power of x plus c1 is minus e. So minus x cube e by 3 minus c2 is 2 by 3e. So this is the solution. Okay, I think that's enough for today. Bye for now.